what if cybersecurity is not what we think it is? What if we made a fundamental mistake in the way that we try to approach information security? Cybersecurity impacts everything, and by that I mean everything on this planet. There are endangered species that are being tracked using geolocation, which means they are impacted by cyber because they are hunters who are trying to use this information in order to capture them and to kill them. There are oil rigs in the middle of the Amazon that are using industrial controllers, and any damage to them would cause damage to the lungs of this planet, which is the Amazon forest. So cyber has been integrated into our environment. There's no more life without cyber. Our life as human beings is totally, completely dependent on it. And as such, we should probably start to look at it maybe a little bit differently and look at it as an emergent property of life. Now, in my talk, I would suggest that in order to understand why we have such a mess in cybersecurity, we need to try to understand a little bit more how life have evolved on the planet, which of course means evolution, or as probably some people in this planet, if they would have that Twitter at those point of time, would probably call that fake news and crooked and whatever, sad. In reality, all organisms are facing chaos. They're facing states of volatility, uncertainty, complexity, and ambiguity, which is how the US Army have defined the state of the world after the end of the Cold War, and probably how many of us felt the day after the Brexit vote. To survive, life have evolved to focus on what is important, and which is above all, obviously, to stay alive, to be able to reproduce. Species that hasn't had that capability got extinct. And the thing is, all organisms face the same problem artificial intelligence system face, which was coined in 1969 as the frame problem. Now, to do it really fast, the frame problem means that when you have a system, and a system, let's say a very simple system, which is you have you're in a room and there's a button and there's a light. From an artificial intelligence perspective, if you need to map it, you need not only to map it's called axioms. So your frame of axioms should be not only limited to the things that are actually being changed. So for example, you not only write, click the button, light turns on, you need to write, click the buttons, light turns on, wall color hasn't changed. Now most of us think that really sounds really crazy, but that comes up because of a reason, which is the fact that you can practically break any, you can probably define things in finite items can be defined in an infinite numbers of ways. For example, any one of you have an age, gender, height, political association, sexual orientation. The list is really long. And because of that, from an organism perspective, for it to actually to know how to survive, it cannot just understand reality. So we don't see reality. I know it sounds like that, and we just like to think that we see reality, but we don't. And the way that organisms have handled it, because from a computational perspective, it's just too hard to try to grasp all the possible different scenarios. In order to handle that variety or complexity, species evolved to look at the world as a purpose, from a vision of purpose. Meaning organism looks at the world from a functional point of view in order to survive. This model of functional perception was suggested by B Peterson in his book Maps of Meaning, which was published in 2009. Peterson, to those who never heard of him, he's a clinical psychologist who used to teach in Howard, and now he's in Toronto University. His latest book, 12 Rules for Life, became like really big bestseller, and sort of he made him a sworn enemy of postmodernist and third wave feminism, which sort of like, this is a capture from a Channel 4 interview, and somebody just added their own perception of what was happening there. In order to understand how organisms work, the strategy that organisms take, as defined by Jordan Peterson as motivation, action, perception schemas, which best can be described as frames of references. The idea behind frames of reference is very simple. From an evolutionary point of view, organisms are driven by the following. They want to know what is, know what should be, and know what the difference between what is and should be. And the last point is know what to do in order to change from what is to what should be. And I would give you a very simple example. Let's say the should be, I would be full and not hungry. So for you at that point of time, the world divides, and this is true for all organisms, the world is divided into tools, which allows you to get to that target that you want, obstacles, which things are going to block you, and everything else which you don't know, and you simply ignore. Obviously, it works great until somebody eats you, and in that point of time, evolution has a solution for that, which is the minute a species is changing and adapting itself, then it can survive. But without the adaptation, they cannot really survive and get extinct. Now, this is true even for bacteria. Bacteria has the ability to identify hundreds to thousands of chemicals. They can identify carbon sources, nitrogen sources, pH changes, and some of them can even have a memory of a few seconds to see if the environment has changed, and according to that to take action. So while we intuitively see the world full of objects, that's not how we perceive the world. From an evolutionary point of view, living organisms divide the world into tools, obstacles, and everything else. What helps us to track this progress of our goals is our emotions. Positive emotions of perceived progress, for example, would enable a system like the dopamine system in our brain, negative emotions of perceived obstacles, paralysis, and anxiety when facing the unknown. Handling the unknown is a key element in evolution. Wired within animals' neurology. The hypothalamus, for example, has two sections. One section is for rapid response, and the other is for exploratory of unknown states. This is why we have two hemispheres. The two brain hemispheres that we have are actually acting very differently. They respond differently to different brain chemicals. And our left hemisphere is mainly focused on things we know. And the right hemisphere is mainly focused on seeing things we are as they are. One allows us to find dinner, and the other one prevents us from becoming dinner. Let's describe it like that, more or less. As human beings, our society, especially since the information age, we became very much left hemisphere driven, and the left hemisphere has its own advantages. It's very good in crunching number, identifying patterns, but it's really, really bad in very basic things. So for example, if you, the example that I give here is Dr. Ian McGilchrist, who wrote a book called The Master and His Emissary, which is a very, 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 very detailed book about the differences between the brain hemispheres. And he gives an example over there that if you have a stroke on your right side of the brain, and that leaves only your left hemisphere functioning, and the doctor would come into the ward and ask, how are you feeling? Most of the patients, or all the patients, would say that they feel okay. They would, even if the doctor would ask them to move their hand, they would say they move their hand, even though they're not psychosis, they're not crazy. This is what the left hemisphere is actually has in terms of capabilities. Another problem of the left hemisphere is that it's very good in logic, and it doesn't really understand anything which is out of logic. So it tries to follow the logic. So, for example, there's something called syllogism. Sorry. I will give you an example. All birds fly. A porcupine is a bird, and all porcupines fly. The logic is obviously correct. So if you would have a brain damage, or if you would shut somebody's right hemisphere, that person would say that this is true. And that is the same hemisphere that is actually handling most of our daily routine when we work with the computer, etc., etc. It doesn't have a language, by the way, the right hemisphere. As part of evolution, social structures started to appear, and with them something called dominance hierarchy. As humans, we track our dominance hierarchy using the same neurotransmitters and the same brain structures, more or less, as lobsters have been tracking it for the last 350 million years. As Eh'den Biber liked to say, it was before trees were there. So I think one of the things which is very, very important for us is that the more creatures that we have from our own species, then the more social behavior started to become very, very important for the survival of the group. Because all herd animals, and we are human beings, our herd animals included, survive only in highly coordinated groups. And this is why wolves and monkeys strategize social behavior, where play, for example, is a learning mechanism. Biological frames of reference and social frames of reference are sort of like stacked together, and they are being decided based on the environment and based on the organism, which has more priority. For humans, we call the social hierarchic structures culture. Eh'den, which is one of the most known researchers for organizational culture, defined it as the accumulated shared learning that a group, as it solves its problems of external adaptation and internal integration. Or as the leading developmental psychologist Michael Tosamo said once, fish are born expecting water, humans are born expecting culture. Our culture is what makes us such a prominent, predominant species. It's not the hardware. There's a scientist called Joe Henrich who wrote a book called The Secrets of Our Success. And he covers up a research that was done with chimpanzees, orangutans, and 2 to 2.5-year-old children. Now, what is interesting about it is that the only area in which we put in the dust and passed all the other primates was when it came to social learning. The other task, we are more or less the same as monkeys. Actually, monkeys are better than us in terms of short-term memory. So we have optimized ourselves to become much more socially driven. So we download most of the information that we have. And because of us, our brain have shrunk. In the last 20,000 years, our brain have shrunk in the size, losing the size of more or less this thing, a tennis ball. So 20,000 years ago, which is nothing in terms of evolution, our brains were much bigger. And it seems that it's actually its ongoing process, and it apparently would become even, our brains would become smaller. We are all exposed to multiple cultures. We live in a Western culture, which is based on Judeo-Christian values. There are religious cultures, there are professional cultures, there are class-related cultures, there are cultures which are country-specific and region-specific and gender-specific, all of them stacked and compose the perception of where am I, what should it be, and what do I need to do in order to change that. Now, what's very special about us as human beings is that we can create our own dominance hierarchies and create our own cultures. So, for example, which no other species can do. So, Comic-Con, for example, is a dominance hierarchy for comic lovers, and hackers conferences would be as a dominance hierarchy for hackers. I need to stop and say that there is one element which is we should probably take into consideration, which we don't really do a lot, is the fact that there is one more variable. We're not really who we see ourselves in the mirror. There's a book called The Microcosm Within, and in the book, William B. Miller writes and explains that we are not really humans. We are a community or a colony or corporation or whatever you would call it, because there's more non-human There's more non-human biomass inside of us than human. It's always something that we cannot really perceive because we look ourselves as human. And that things impacts our perception of reality, our motives, our moods, our feelings, all the stuff that we usually take care of. Now, I guess that by now some of you are wondering why the hell did I talk of all these things about biology and neurology and sociology and psychology, and what does this have to do with cybersecurity? Well, I will give you a hint. Now, with a raise of hands, does anybody know who this guy, Shadow, is? Nobody? So, that guy's name is Norbert Wiener. Does anybody heard of this guy? Raise of hands? Good. So, that person, Norbert Wiener, a child prodigy, the 6th ranking mathematician in the world in his time, a Harvard Math PhD graduate at the age of 17, and his Wiener filter allowed anti-aircraft fire to protect London from World War II V1 missiles. So that guy was slightly smart, but the reason why he's known is because he had he had used the term cybernetics, which comes from the Greek word Kubernetes, which means steering, like steering a ship. We are right now in the cyber revolution, and cybernetics is a science language. It's a scientific language that describes complex phenomena that a single discipline such as physics and chemistry couldn't explain. It is transdisciplinary language that can be used to describe all systems, but extremely effective for complex ones: biological, managerial, technological, social structure, etc., etc. Cybernetics was created by a group of scientists from multiple domains of knowledge that met between the years 1946 to 1953 in 10 events which are known as the Macy Conference. It gave rise to the information revolution, to feedback loops, to Shannon information theory, and much more. Now, the reason why cybernetics is very important is because it allows us to look at things from a holistic point of view. Cybernetics typically treats any given particular machine by asking not what individual acts would be produced here and now, but what are all the possible behavior that it can produce. Now, try to think about Facebook, for example, and the data leakage that was happening. If they would have been using cybernetics, they could not have had a situation that they could have said, we didn't know about what was happening. It can describe organisms, their lives. I would click this one and I would go to this one because I think I'm running out of time. Yeah, probably am. So everything I told you today can be explained by cybernetics. And since we don't have an isolated world anymore, there's no more isolations between cyber world and normal world, between IT and HR and all other departments, our companies and our societies are practically using wrong methodology. The methodology that almost all organizations are using are reductionist methodologies. You can look at it in any way that you would look at an org chart, for example. It's very much structured from the head to lower down, while cybernetics talks about the emergence, and cybernetics is all about communication. And that's a huge, huge difference. It's almost like the difference between the left hemisphere and the right hemisphere of the brain. I will finish up with one point, which is cybernetics, cybersecurity and cybernetics research. So relatively, that has not been looked at, and it's quite a shame. I brought with me some research papers, which are here and mentioned there. One of the research papers, I think is the last one, application of cyber, yes, that one. There's actually a mention of it that says that this should not constitute as a document that should be restricted according to the arms trade restrictions or something like that. And they mention inside the document that whatever they talk about can be used for an attackers as well. So there's quite a lot of, there's an interest into this approach, and that approach of cybernetics have a huge impact in terms of management, in terms of risk management, management of organizations, risk management, and cybersecurity. But sadly, we would not have the time to go over it, so I would finish with that, which is the end, or sorry, fake end, because there's no end in cybernetics. Everything is circular. So thank you very much.